All right, so let's continue. Now, what we're gonna do for this part is basically the rest of this packet, right? That we didn't get to, which was just fractions. Should be real simple, real nice. All right. So the first thing I'm gonna start off with is nothing complicated, right? So this is called simplifying fractions. So a fraction is a way to represent parts of a whole, right? So the fraction 2 over 3 or 2/3 represents two of three equal parts, right? As you can see right here with the pie diagram. In the fraction 2/3, right? The 2 is called the numerator, the number that's on top, and the 3 is called the denominator numbers on the bottom, right? Think of denominator being like everything, and 2 is just what you're looking at or what you want to know. All right, that's like a statistics kind of lingo right there. And two out of the three um parts, right, of this whole are shaded in. So that's how that's represented. A, yeah. Just just one. Yeah, yeah. I'll try to see how we fit. Make sure next time they don't. I mean, yeah, but they were unsure whether to come back or not because they thought that the calculator thing was optional. Yeah, and I didn't know, so I was like, I guess. Yeah, yeah, yeah. Okay. You're welcome. Yeah, yeah, yeah. All right, so fraction, right? So a fraction is written as, for example, A over B, right? So some number over another number, right? Where B cannot equal zero. So it's illegal for us to divide by zero. So for a fraction, the denominator can never be zero, right? Um, just to throw some big vocabulary out at you, that's called undefined, right? Anyway, A is a numerator, B is the denominator. A fraction represents parts of a whole. So the denominator B is a number of equal parts of the whole, right? Has been divided into. And the number A represents how many parts are included in like the situation or whatever. Right? So fractions that have the same value are equivalent fractions. So the equivalent fractions property allows us to find equivalent fractions and also simplify fractions. All right, so we're going to take a look at this. I'm going to get a little theoretical on you, just a little bit, all right? It'll all make sense towards the end, right? So equivalent fractions property. If A, B, and C are numbers where B cannot equal zero, C cannot equal zero, then A over B is equal to A times C over B times C, and A times C over B times C is equal to A over B, right? So what's going to happen in the future is I'm going to have some type of fraction that's going to have A and C together and B and C together, and I want to break out the C part so that the C's can cancel and I'm left with A over B. That's the simplifying of a fraction, right? Let me elaborate on that a little bit. All right. So a fraction is considered simplified if there are no common factors other than one in its numerator and denominator. For example, 2 over 3 is simplified because there's no common factor of 2 and 3, but 10 over 15 is not simplified because 5 is a common factor of the numerator, which is 10, and the denominator, which is 15. So we simplify or reduce a fraction by removing the common factors from the numerator and the denominator. A fraction is not simplified until all common factors have been removed, right? If an expression has fractions, it is not completely simplified until the fractions are simplified. Sometimes it may not be easy to find common factors of the numerator and denominator. When this happens, a good idea is to factor the numerator and denominator into prime numbers and then divide out the common factors using the equivalent fraction property. All right. I'm really interested in that last part. I'm going to show you guys how to do that. All right. Particularly because we can't use calculators. All right. So here they ask us to reduce this fraction. Full disclosure, I don't know how to do it. Right. So here's what we're going to do. All right. I have negative 315 over 770. Right. So what am I going to do? I want to break up each one, the numerator and the denominator individually, and I want to see what numbers multiply to give me each one, right? So what I'm using is something called the fundamental theorem of arithmetic, right? Prime factorization is another word for it. So let me start off. Let me start off with the 315. Now, two numbers that multiply to give me 315. Looking at it, I could just tell that 5 goes into 315. So this is going to be what? 5 times, let's see what this is. 15. This is 30, 36. 6 times this is 30. This is 1, 5. So that's 3. Okay, so this is 63. Now, here's the thing, right? 5 is a prime number, so I could stop right here at 5. But 63 is not prime. I could go further, right? I could break that into what? Not 3. I mean, yeah, 3 times 21. Yeah, but something else I'm thinking of. I'm thinking of 7 times what? 9. Right? Now, oh, so I shouldn't have circled a 9. 9 is not prime. 9 can get broken down even further. 9 would get broken down into 3 times 3, right? So that means that 315 is 5 times 7 times 3 times 3, right? Let's write that up here. 5 times 7 times 3 times 3. Questions on this? You're good? All right, so my next goal is I want to do the same thing to the 770, right? This could get broken up into 7 times 10, which could then further get broken up into 5 times 2, right? So now what do I have up top? I have 2 times 5 times 7, right?
So where you,
Mhm.
so where you put them in matter at all?
Say it again.
So where you.
Got you. You know what I realized? I think this is supposed to be 77. Made a mistake there. And then this is 7 and 11. That sounds better. Yeah, that sounds better. So it should be 2, 5, 7, and 11. My mistake. Sorry about that. Sorry about that. Anyway, what am I trying to do here? I want to cross out the like terms, right? So I see a 7 on top. Oops, hold on. I meant to do a different color. So I see a 7 on top. I see a 7 on the bottom. I see a 5 on the bottom. I see a 5 on top. And that's it. That's what I'm left with. I'm left with 3 times 3 over 2 times 11, which is not bad, right? So it'd be negative 3 times 3 over 2 times 11. So this is negative 9 over 22. And that's it. That's the reduced form of this equation. Questions on this, anybody? So when you get some number you don't know how to break it down, use prime factorization, break it down to those basic prime numbers, and then apply it wherever you need. Good? How you feel? Good? All right. I want to give you guys a little bit of notes. This is like a procedure I'm about to show you. So how to simplify a fraction. Step one, rewrite the numerator and denominator to show the common factors. If needed, factor the numerator and denominator to prime numbers first. And step two, simplify using the equivalent fractions property by dividing out the common factors. And step three is multiply any of the remaining factors together. Okay. Next, we're going to talk about multiplying and dividing fractions. So many people find multiplying and dividing fractions easier than adding or subtracting fractions. To multiply fractions, we multiply the numerator and multiply the denominator. So this is fraction multiplication. If A, B, C, and D are numbers where B does not equal 0, D does not equal 0, then A over B times C over D is equal to AC divided by BD. To multiple fractions, multiply the numerator and the denominator. Questions on this? This is just showing you how to do multiplication with fractions. I always say if you can just go from left to right, you're good to go. That should be it. So in multiplying factors, the properties of positive and negative still apply. Of course, is a good idea to determine the sign of the product as the first step. All right. So we will multiply a negative by a negative, so the product, right, will be positive. So in multiplying a fraction by an integer, we we may be helpful to writing to write the integer as a fraction, right? So any integer a can be written as a over 1. So example 3 is the same as 3 over 1. Here, you guys try. Try that out. Let's see how this goes. Treat fractions like you would treat any number, even a whole number, and it becomes easier. So let's start it off. A negative times a negative is a positive, and 12 over 5 times 20 is what? What? Probably. Yeah. E 72? No?
20, do that twice. Remember,
Uh, 20 divided by 5 is what, 4? It's 4, and then 4 times 12, 48. All right. Look, so you have negative 12 over 5 times negative 20x over 1,
right?
right? So I would just cross multiply negative times positive. So this would become 12 over, let's say negative 5 times, so it'll be positive, uh,
40.
40. Yeah. Because I'm thinking 5 goes into 5 once, 5 goes into 40 4 times. And then 4 times 12 is 68. No, 48, excuse me. That's how I would do it. Your ways could work too, as long as we get the same answer. It's okay if you just multiply it straight across and then reduce it at the end. That's fine too. Question on it? Good. How to do a cross? So it's multiplication. So what you do is if you can eliminate a denominator on one side and a variable on the other, you're good to go. You just take the final at that point and see what happens. I'm sorry. You want to see another one or are you good? Okay. Got you. Try this out.
Do you have a preference of which method to just sort of cross it or to just?
Just give me the right answer. So what you guys get for this?
33.
Okay. Week 2. What you got? Mm-hmm. Mm-hmm. Multiply straight across. It's straight across. And that's it, top and bottom. Then you can reduce it. Okay. So let's see. I have 11 over 3 times negative 9a. This is 11 over 3 times, right? Negative 9a over 1.
So is it, the
Mhm.
previous problem have the negative not on the, did not have the parentheses?
Mm-hmm.
But this one does, so it's only applied to the
Right.
numerator.
Yeah.
Okay. I knew that.
So then now we could just 3 goes into 3 once, 3 goes into negative 9a, 33%. I'm sorry, what am I talking about? 3a times. Then you just multiply straight across. 11 times 3, 33a. Oops. 33a. Yeah, that's it. Over 1, which is just 33a. Negative, of course. All right, questions on this? So you put the whole number part over 1 and then just go ahead, straight ahead.
Wait, isn't that
Mhm. Uh, so diagonal is, what is it? I'll get back to you. One of the textbooks has something in it about that. Hmm.
wait, then how much three goes into nine? Well,
3 goes into 9.
yeah,
3, so 3 goes in 3a times. Well, you know what? It should be this. It should be negative 3a. That makes more sense. And then you just multiply times 11. Okay. So now that we know how to multiply fractions, we are almost ready to divide. Before we can do that, we need some vocabulary. So the reciprocal of a fraction is found by inverting the fraction, placing the numerator in the denominator and the denominator in the numerator. Right? The reciprocal of 2 over 3 is 3 over 2. So since 4 is written in fraction form as 4 over 1, the reciprocal of 4 is 1/4, 1 over 4. So to divide, right, fractions, we multiply the first fraction by the reciprocal of the second. That's it. So fraction division. If A, B, C, and D are real numbers where B cannot equal 0, C cannot equal 0, then and D cannot equal 0, then we have this formula here. A over B divided by C over D equals A over B times D over C. So to divide fractions, we multiply the first fraction by its reciprocal or the second of the second. This is called find the quotient. One second. So 7 over 18 divided by 14 over 27. 7/18. (14/27). Like that, right? And then what you want to do is you want to take the reciprocal of the second one and then multiply it. So this is going to become 7/18 times 27/14. Reduce it. 7 goes into 7 once, 7 goes into 14 twice, 9 goes into 18 twice, 9 goes into 27 three times. Multiply straight across, we get 1 times 3/2 times 2. All right? And this will equal 3/4, 8. And that's it. Questions on this? So keep, change, flip. Keep the first fraction, change division multiplication, flip the second one. That's the trick to doing this. Right? Try this.
Full 8 from.
8. It's right as 4, right?
Yeah.
Whoops. Sorry about that. Check you some messages. Let's take a look. So I have -7/27, right? Remember, keep, change, flip. So I'm going to change that division and multiplication. Then I want to flip the other side over here. So this is going to become 30, excuse me, -36/35, right? Reduce and then multiply straight across, right? So 7 goes into 7 one time. 7 goes into 35 five times, right? And then we could do, let's try 3. 3 goes into 27 9 times. 3 goes into 36, I think 12 times, right? Could do another 3. 3 goes into 9 3 times. 3 goes into 12, I think 4 times. And just multiply straight across. A negative times a negative is a positive, and then this is 4/3 times 5, 15. You guys got the same? No? What did I do different? The what? 1/5?
Uh, I just did math. I got reason like 1 times 4 was 5,
Yeah.
but that's a lot. But also, isn't the first fraction is negative on the whole fraction itself?
Yeah. The same thing.
Oh,
So it doesn't matter. Yeah. So if I have -1/5, wait, hold on. Let me do that again. If I have -1/5, or if I have like 1/-5, or if I have -1/5, they're all the same. Yeah. It all means the same kind of idea, same thing. Yeah.
but if you only have one negative in this equation, then you end up being,
Mhm.
oh yeah, it wouldn't, it's all the same.
Yeah, yeah.
Thanks.
You're welcome. All right, let's get to the hard part. All right, so this was the easy part. Let's get to the hard part. All right. I mean, it's not too hard though. Y'all are like really, really smart, but it's still the hard part, you know? So we're gonna add and subtract fractions, right? So when we multiplied fractions, we just multiply the numerator and multiply the denominators straight, right? Across. To add or subtract fractions, we have to have a common denominator. That's the hard part. So they have to all have the same denominator in order for me to add or subtract the numerators. That makes it challenging. So let's take a look. So just to show you where we're coming from. So fraction, addition, subtraction. If A, B, and C are numbers where C cannot equal 0, then A over C plus B over C is equal to A plus B over C, and A over C minus B over C is equal to A minus B over C. So to add or subtract fractions, you add or subtract the numerators and place the result over the common denominator, right? The least common denominator, LCD, of two fractions is the smallest number that can be used as a common denominator of the fractions. So the LCD of the two fractions is the least common multiple of their denominators, right? So the least common denominator, LCD, of two fractions is the least common multiple of their denominators. Just letting y'all know that. So after we find the least common denominator of two fractions, we convert the fractions to equivalent fractions with the LCD. Putting these steps together allows us to add and subtract fractions because their denominators will be the same. Let's take a look. So I want to add or subtract these fractions right here, right? So I have 12 and I have 18. Now, let's say that we had trouble, even though 12 and 18 is kind of simple. Let's say we had trouble finding the LCD. Here's a way that you could find it, right? Take the prime factorization of each one. So 12 we know is what? 12 is the same as 1. Um, like what numbers give me 12? 1, I think 2. You give it to me 3. Wait, hold on, wait. 6 times 2, so 6 is 3 and 2, and another 2. Yeah, this is it. 3, 2, 3, yeah. 4. That's it. Right? How about 18? I want the numbers that multiply to give me 18. So I'm thinking of like 2, 3, and 3. Let me erase this one. I don't need that. Right? Because 18 is just 9 times 2 or 2 times 3 times 3. These are the prime numbers, right? Here's what I'm interested in. I'm interested in what do they have in common, right? So they both have 1, 2. They both have 1, 3, right? But one of them has an extra 3, one has an extra 2, right? So I want, when I say LCD, I want the largest and first number that both numbers goes into, if that makes sense, right? So, let's put it all together. Another way you could do it, take one of the numbers, like say like the 12, which is 2 times 2 times 3, and just put the missing side in there. So this is the LCD right here. All I did was take the 12, right? And then I put whatever's missing, whatever's extra into this. And that's it. So 2 times 2 is 4 times 3 times 3. That's what is that? 3, 6, 12 times 3, 36. So 12 goes into 36 3 times. 18 goes into 36 twice. And that's it in a nutshell. All right. So hold on, let me change my color. I have 7 over 12, right? What number can I multiply the 12 by to make it 36? By 3, right? But what I do to the bottom, you gotta do to the top. I have 18. How can I get that to 36? Multiply it by 2, right? But what you do to the bottom, you gotta do to the top, right? Bam. Now the 12 times 3 is 36, 18 times 2 is 36. At that point, I could just work with the numerator. So all I have to do is worry about 7 times 3 plus 5 times 2. All of that is over 36. All right. Adding these together, right? 2 and 3 will give me 5. 7 plus 5, what's that? 10, 11, 12. Wait, I'm sorry. Hold on. My fault. I'm looking at that like a decimal. I'm sorry. Let me try that again. 7 times 3 is 21, plus 5 times 2 is 10 over 36. But adding those together, I get 31 over 36. That's it. Sorry about that. So basically, once I had the same denominator, I could just multiply, add whatever straight across, and then that's it. Questions on that? Want to see another one? Let's take a look at another one. All these are on your packet too, so you'll have more practice after, or like when you go home. Yeah, try that out. Done? All right, let's take a look. So 12, I know is 6 times 2, which becomes 3 times 2. 15, I know is 5 times 3. Take one of them. Let's take the 12, for example. 2 times 2 times 3. Now let's look over at the 15. I already have 1 3, just missing the 5. And that's it. So 2 times 2 is 4. 4 times 3 is 12. 12 times 5, 60. Not bad, right?
So,
Oh, I didn't even get to the top yet. Yeah, this is just the denominator. So the common denominator is 60. So now you have 7 over 12, right? Plus 11 over 15. So how do I make a 12 into 60? I have to multiply that by 5, right? But what you do to the bottom, you got to do to the top. How do I get 15 to 60? All right. I have to multiply by multiply 15 by, I believe it's 4. Right? It's 20, 0, 2, 4. Yep, that's it. But what you do to the bottom, you gotta do to the top. Now just a little bit of math. 7 times 5, 35 plus 11 times 4, 44. All over 12. All right. Little math, something like that. Right? Questions on this?
this, number 15 is private.
The 15 is what?
Like the common or like the common.
The LCD. Yeah, yeah, yeah.
Yeah, there's 3 on 12, there's 3, 2, 2, 15 is 5, 3.
Right.
So do you put them all together?
You can. So if you put them all together, that's called a common denominator. And you're welcome to find the common denominator and do this. The only thing is that when you get the answer, you have to reduce it. So if you prefer to do that, by all means, you won't lose any points. You know, me personally, I like to cancel out before I get down to that point because I want the questions, whatever, to be like, real nice and legible. You okay? All right, let me give y'all some instructions real quick. So, little how to add or subtract fractions. Step one, do they have a common denominator? If yes, we're gonna go to step two. If not, rewrite each fraction with the LCD, least common denominator. All right, then you want to find the LCD, right? Change each fraction to an equivalent fraction with the LCD as its denominator. Step two, add or subtract the fractions. Step three, simplify if possible. Not all the time, but if it's possible, right? So now you guys have all of the operations. Let me just give you a nice little summary real quick. Nothing fancy, just a nice little summary. So fraction multiplication, A over B times C over D equals A times C over B times D. Fraction, so multiply the numbers and multiply the numerators and multiply the denominators straight across. Fraction division, multiply the first fraction by the reciprocal of the second. Keep, change, flip. Keep the first fraction, change the division multiplication, flip the last one, right? Fraction addition, add the numbers and place the sum over the common denominator, right? So you want to add them if they have the same denominator, the numerators, and then that's it. And then reduce if possible. Fraction subtraction is the same thing. You subtract the numerators and place the difference over the combo denominator. So to multiply or divide fractions and LCD is not needed, right? To add or subtract fractions, the LCD is needed. Okay? Please, please. You want the other one too on top? Okay. There you go. You're welcome. Not a problem at all. Oops. So, try this out. Okay. So this is actually a good example of this question here, right? So what you were saying, if we could just put them together, I'm gonna put them together and I'll show you what happens, right? So 5x over 6 minus 3 over 10, right? Very simply, I see 10 multiplying the bottom by 10. What I do to the bottom, I do to the top. I see 10, I'm multiplying it by 6.
Like, time, the same.
Exactly. And what I do to the bottom, I do to the top. So I'm gonna end up with a larger answer, but it can be reduced. That's the trick, right? So this would become what? 10x minus 18? 6 and 6 is 12. It's yeah, all over 60, right? Now the thing is that I can actually reduce this a little bit, right? So I'm looking for a number that goes into 10 and 60, or 10x minus 18 and 60 evenly. It's actually 2, right? I could factor out 2. So I'm left with 5x minus 9 over, let's say, 2 times 30, right? These 2's cancel, so I have 5x minus 9 over 30, and that's my answer. So that's if you don't want to find the LCD, just put them together and be like, whatever happens, happens. But at the end, we have to reduce it. That's the tricky part. That's the tricky part. You know? Mhm. What you got? Tell me. 15x over 30. Oh, 16. How did you get 16? That's a good question.
Six, 3 times 3 times 6 should be equal to 25. 5 times.
Okay.
I don't think that's exactly right.
Remember, your goal here is you want to make the bottom numbers look the same. So 6 and 10. The LCD really here is 30. That's the truth, right? 6 goes into 30 and 10 goes into 30. So with 6 to go into 30, you would have to do 6 times 5, which is a bind to the top. So that'd be 25x. For 10 to go into 30, it would have to be 3, right? And then you add the 3 on top. And then you want to subtract those two answers once you get it. You should get the same answer as me. Yeah,
9.
right.
Yeah, but you get 25x minus 9.
Mm-hmm. I see what you mean. Hold on.
Uh,
30, 25, 30. No, I agree with you. Same thing. Maybe I messed up. I did mess up. Look at this. I said 5x times 10. It's not 10, it's 50, right? And then you pull out the greatest common factor there, which is 2. It still is 2, which makes this 25x minus 9, like that.
you can't find any further, right?
Oh, I can't cancel the 5
I was
because
talking about on the last, very last 25x minus 9, you can't simplify that further.
no. Can't survive any further. That's it.
That also confusing. So it's
Yeah.
one, but then how did you
Yeah,
simplify past?
I got you. Yeah, that's it. That's our goal for this. All right. We're kind of making good on time. Would you guys like to see another one like this? Okay. After this, we're gonna do something very similar to what we did earlier this morning, where I'm gonna give you an expression and then you're just gonna plug in the numbers and do the math on it. You know, same old thing. That's like the last question on this. You know, you just plug in the number for the variable and then boom. You know, nothing crazy. Yeah. Well, yeah, try that out. So yeah, when you guys go home, use these packets to practice. I'm okay with you guys using Google or AI to verify your answers. No problem with that. You know, just make sure you guys get the steps down packed. if you're using AI, what's nice is that you can actually ask AI to show you step by step how to do it. So I kind of like that aspect of it because then you're learning, because I want you guys to learn how to do this. Because next week on Thursday, when we take the exit, no calculator. So
The use you have this.
this will be on it. Yeah, yeah. All right, ready? Let's take a look. So I got 3a over 4 minus 8 over 9. This case, I kind of have to put them together because there's nothing. I multiply this by 9. What I do to one side, what I do to the bottom, I do to the top. Multiply this by 4. What I do to the bottom, I do to the top. Little math, 9 times 3, this is 27a minus 8 times 4, which is what? 16, that's 32. All over 9 times 4, what's that? 36. All right. Now, because of the variable, I can't combine like terms, so that's why I'm kind of just leaving it like this. Go ahead.
I went a big roundabout way, I did it to the lowest of the,
LCD.
yeah, can you do that, is it fine if I just did it on like 3 times 3 times 2 times 2?
Yeah, yeah, yeah. That's fine. If that helps you to find it, I like that method actually. I like that a lot. Yeah. But yeah, so I'm just here thinking, is there anything I could pull out with this? But there doesn't appear to be. So that's the final answer, this part right here. Let's look at the other part, part B. So part B says 3a over 4 times 8 over 9. So what you could do before you even multiply this, just reduce it, then multiply straight across. 3a goes into 3a 1a times, and 3 goes into 9 3 times. 4 goes into 4 once, 4 goes into 8 twice. Multiply straight across, what do we get? 2a over 3. And that's it. All right. Not so bad, right? All right, let's look at that last part real quick. Now, the questions I gave you is not going to be as challenging as what we're about to do right now, but it'll be fun to see. So we're going to evaluate variable expressions with fractions, all right? So we've evaluated expressions before, but now we will evaluate expressions with fractions. So remember, to evaluate an expression, we substitute the value of the variable into the expression and then simplify. So let's look at an example real quick. This is all going to pop back into your head, promise. All right? Boom. So I have what? 2x squared y when x equals 1 over 4 and y equals negative 2 over 3. So I'm just going to take the value and plug it into the expression and then solve it, you know? So this is going to become what? 2. But instead of the x, what do I have? 1 over 4 squared times y, which is negative 2 over 3. So all I did was just take the variables and plug them in. That's it. After that, a little bit of math and we're done, right? So this is going to be what? First, remember, we always do exponents first, right? So I'm going to do 1 over 4 squared. Let me do it on the side so you can see what's going to happen. When I say 1 over 4 squared, it's the same as me saying 1 squared over 4 squared, right? So this becomes what? 1 over 16. That's all that is. So now let's look at what I have. I have 2 times 1 over 16 times negative 2 over 3. Just like that, right? After that, it's the same thing. I'm multiplying a fraction by a fraction, just going to multiply straight across, right? So I'm going to rewrite the 2 in the front as 2 over 1 times 1 over 16 times negative 2 over 3. That's it. All right. I could probably reduce the 16 a little bit. 2 goes into 2 once, 2 goes into 16 8 times. I could probably do it again. 2 goes into 2 once, 2 goes into 8 4 times. And now what do I have? I have negative 1 over 4 times 3. Final answer, negative 1 over 12. That's it. 3, 6, 12. Yep, that's it. Questions on this, please. Anybody? Does it make sense?
Sorry, can you go over the,
Yes.
simplifying
Sure.
16?
Sure. If you don't want to do it that way, if you want to multiply it straight and then simplify it, that's cool too. That's all right. I'm just trying to save on the math. Yeah.
2/16 times.
Mm-hmm. So yeah, so it's 2 times 1 times negative 2 over 1 times 4 times 3. Right? I'm sorry, 1 times 16 times 3. Sorry about that, right? So the 2 can reduce the 16 on the bottom, can be reduced by it. So 2 goes into 2 once and 2 goes into the 16 8 times. But then I have another 2 on top and I can do the same thing to the 8 this time. So 2 goes into negative 2, negative 1 times, and then 2 goes into 8 4 times. And then after that, just multiply straight across. I have 1 times 1 times negative 1 over 1 times 4 times 3. Right? So this becomes negative 1 over 12. And that's it. Right? Questions on it?
Yeah, if we get the removable, just, a crossway is just the same thing, but you just have to simplify it again, right?
Exactly. Yeah. Yeah, if I had multiplied it straight, I would have had 4 over I'm thinking that's 8, that's 148, like 4 over 48.
Yeah.
And then that would reduce to 1 over 12.
Yeah.
Yeah. So yeah, that's completely correct as well. You could do that as well if you like that method better. Yeah. No, it's one single answer, but different processes to get to it. Yeah. Let's try another one. Okay, give this a try.
At.
Okay. All right, let's try. All right. So I have 3, but instead of the A, I'm going to write in what A is, -2/3. And then I'll have the B. Instead of B, I'm going to write in -1/2 and then squared, right? Order of operations, deal with the exponent first, right? So I'm just going to do this in the corner right here. So -1/2 squared is the same thing as -1 squared over 2 squared. Call that 1/4. Let me rewrite this. I have 3 times -2/3 is 1/4. Go ahead.
The negative on the, I thought if it was parentheses, it was, I thought it was not.
It could be either one, top or bottom.
No,
Yeah,
but it's negative.
yeah, yeah,
Possibly, you're right.
yeah. But I'm saying if you want to put the negative on the 1 or you want to put it on the 2,
Yeah.
it's fine. Yeah.
Because it has a parentheses, that means it's always gonna turn out negative, right?
No, no, the negative is going to repeat with it, so it's going to become positive.
Well, negative, means twice, right?
No, twice means positive. 3 times. So, all right, if it's an odd power will give you a negative. But if it's an even power is a positive. So to the second power, like -1 to the second power is +1. But like -1 to the third power is -1.
Yeah.
Yeah. And then that cycle just repeats as the numbers increase. Right? After this, I'm gonna rewrite this as 3/1 times -2/3 times 1/4. After this, just reduce it a little bit, right? 3 goes into 3 once, 3 goes into 3 once, 2 goes into, this is -1, this is 2. Multiply straight across. This is -1 times 1 times 1 over 1 times 1 times 2, -1/2, and then that's it. Right? What do we think? Questions? It's good? Good, good. All right, so practice this. We have about half an hour. You guys might even be able to finish it here. Yeah.
So then there's no parentheses, means that it only gets applied to the last, to the one, hypothetically one,
Right.
and that.
Yep.
You said you were gonna go over there's gonna be another day where you go over like there's no calculators, the
Yeah.
exponent method.
Oh yeah. I can do it right now. What I'm saying, right, is if I'm going to use the 2 example again, just because 2 is nice, you know? So if I have -2 squared, right? This means -2, and just put in parentheses, times -2.
Right, but
Mhm.
I'm talking about
Like what?
higher exponents where you have to use the equation.
Like natural log and all of that?
So, because I believe the equation is.
Yeah, give me one.
X times X or say n is the variable for your exponent, and
Mhm.
X is, X, to be X times X squared to the nth power and all that in parentheses, or, in the parentheses, it would be then n. Yeah, I forgot the equation, but it's something like that. And it depends if it's even and it's odd, if it's even, you have to do
Yeah.
n-1,
Uh-huh.
that equation. And it works. I remember you just used it.
It's even, you do n-1.
Just look it up. They just need you to
It sounds interesting. Yeah. Let me take a look.
There's
Yeah.
no big
Yeah. You don't mean like this. What is
by square.
oh, so like raising a power to a power.
Uh,
So like if I have x squared raised to the third power like that.
no, this is just to solve like this. So if it was like give x to the nth power,
Okay.
it would be equal to, and if this is only, if this is so x to the n, if n is odd, then you would do x times x squared to the nth power minus one divided by two. Yeah.
The n power divided by one
One divided by two.
oh, like raised to the n minus one power
Yeah.
divided by two. Got you.
And that would give you, that's basically how you would solve it if it was like a very high exponent. If only
It's
if it
true.
was high.
It's true. Yeah.
And then if it was even give you something else. But the only
Yeah.
problem I have with this is that what happens if you have a negative?
In the n, if the n is negative.
They write
Oh,
something.
so I can show you that. Look, if I have x raised to the, well, let me do a number. Just make it nice. If I have 2 raised to the negative 2 power, for example, right? What that means is it means 1 over 2 squared, which becomes 1 over 4. So anytime I have some variable x raised to a negative power, let's say like negative a, this becomes 1 over x to the a power. That's the formula for it. Yeah. Fun stuff. You will get into that. Not now, though. Not in this, like what we're doing right now, but when you get into the next class, it will be there.
That new semester.
Yeah. Like the actual 28 class, it'll be in that.
Yeah, I just want to know because no calculator is threatening.
Nah, don't worry. No calculator is actually a blessing. So that means that legally speaking, they could ask you what is 50 minus 3. But if you have no calculator, it's gonna probably be like what is 6 minus 2, so smaller numbers. That's all the no calculator means. Yeah. Not my rule, by the way. This is what they want. So yeah.
Actually,
Yeah, please.
because I already have this half learned.
I got you.
So I can have it.
Yeah.
This is the formula.
Awesome. Okay. Recursive version. Awesome. I was reading through it. Exponential by squaring. Okay. But yeah, it's basically like showing you how to break down an exponent if it's even or odd.
Yeah, no, I know that. I'm
Yeah,
just
yeah,
saying.
yeah.
I know the steps if it's odd or even, but the only
Yeah.
problem is, what are they talking about when it gets to negative here?
Oh, that's the same thing that I was showing you, that when you have a negative power, it just goes to the denominator and becomes positive. That's all it means.
Yeah, but
Yeah.
how would that function in the formula?
Yeah. So the reason why on the is it the right hand side, this side, when you have that negative power there, it comes back to the original. So that's what they're trying to say. Like you see how mine is negative, that's why mine can be like that. But what theirs is positive. So they have this, right? And the only way to have that would be if this was 1 over x to the n, and then this was to the negative power, negative n or whatever.
So
Let me erase the n there. Yeah. Because then it would come back
and
to
then
the
you just
original. Yeah.
negative x to the negative power.
Yeah.
So it's just saying that if there's a negative exponent, you can't use the formula listed, you have to solve it on
Right.
its own whole thing.
Right, exactly.
Okay.
Yeah. Fun stuff. Fun stuff. Yeah. If how can I say this now? Everything that you're looking up in the wiki, it might not all be in 28. Some of it's gonna be in like math 30, which is pre-calculus. So, but you will see it for sure, Yeah.
Yeah, I guess I was trying to look up the basics and I just.
I got you. I got you. I got you. Yeah. Nah, this class is like basic basics. Like yeah. Even that information that you have there, I don't even know if you really need all of that for calculus. Like calculus is kind of simple. Yeah.
I don't know, my brain likes to know,
Yeah.
I really understand it fully.
I understand completely. I like that. I like that. Yeah. So yeah, just knock out the packet, and then you guys should be good. Is it okay if I stop sharing, close this and all that?